Welcome contemporary topics in mathematics students to the lesson for 11.1. We are dealing with percents here. So percent change, that's something you should know by the end of this, or you could call that percent of increase or decrease, and the percent markup on cost. We should know how to do all those sorts of things by the end of this lesson. And as always, making sure you're using those extra examples in the book. If you need help with a specific example or you want to see another one like it, always look at those extra examples. Let's get rolling now. So here, first of all, we will define the word percent, what it means, what it literally means, and what we do to do that. So a percent, all it is a ratio of some number to 100. And then write this down too, little interesting tidbits, and it will help you remember what to do. Literally it means per 100. It was a Latin phrase, per centum, where we get our word percent from, per centum meaning per 100. And if you think of cents in a dollar, this is how I remember this. Cents in a dollar, there's 100 cents in $1. So per cent is per 100. Alright, so let's get started with some examples. Let's check this out. It is time already to take out a different color. So we're going to be color coding quite a few things here. Please make sure you pause the video if you need to. Go get a different color of some sort and then come back when you're ready. So here we go with that. This is the way to deal with fractions and change them to percents. First of all, how do I change a fraction to a percent? So that's the kind of the heading for this. Rather than write that down and then do an example, I'm going to do it within the context of an example here. So let's just take something pretty simple. We'll take 3/8, so 3 divided by 8. To change that to a decimal, if you didn't know what that was off the top of your head, which I would expect not too many of you would, you would either do long division or take out a calculator. For us, we can use calculators most of the time in this class. We're going to use a calculator to figure this percent out. 0.375 is that as a decimal. That's not a percent. So how do I change this to a percent? Well, you may know this already. I hope you do, because it's something you should have known for some of the past classes that you've taken. Just move it 2 spots here to the right. So we are going to, first of all, let's make a little note right here. How do we go from here to here? Well, we converted to a decimal using a calculator, or you could have actually used a long division as well. So convert to a decimal using calculator or long division. So everything that's going in red here, you should be doing in your different color, whatever color you've chosen. So calculate. So decimal using calculator or long division to go from the fraction to this, and then we're going to move it 2 spots, and that's going to equal for us then 37.5. So to go from a decimal to percent, you probably already knew that, but just in case you didn't, we're doing an example together here. 37.5% would be that. So per 100, what is 3/8 equivalent to per 100? It's 37.5 per 100. It would be saying that in a sense. So let's write one more thing down here in our different color. What did we do here? Basically what we're doing to do this and this, similar to what we did for when we had our metric system unit, where we're like thinking of like times 100 divided by 100 times different powers of 10. Here we multiply by 100, multiply by 100 because we're talking about percent, and then we added the percent symbol. Add a percent symbol. And then one extra little side note here. If you're going from the decimal to a percent, you're going to move the decimal 2 places to the right. The decimal goes 2 places to the right. And then let's say, still in a different color here now, let's say we wanted to go from a decimal to a percent. If we started off with that, You might say, well, didn't we already just do that up here, Mr. Wagner, right there? We went from a decimal to a percent. You're exactly right if you say that. But let's just do an extra example. This time I'm going to have a decimal that's bigger than 1, just to see the difference. I meant to write a 3 there. Let's go 2.3691. Same idea. Move it 2 spots to the right. My question to you is that okay? Can you have a percent that's more than 100? Can you have something that's more than 100%? Sure. You could have maybe the percent of increase of something going up by more than 100%. Maybe the cost of gas just went up by 300%. It just tripled, in other words. That's a possibility. I hope that never happens, but it seems like that's happened over the past few years, actually. Gas has just been going crazy. But 236.91%. This would be our final answer. You could have something over 100%, just to show you that that can happen. So let's draw a little arrow here in a different color, and also here. That applies to both of these problems here. And so with this one, we're still moving it 2 decimal places to the right. We're doing percent to decimal. If we switch this around, if we went percent to decimal, I said percent to decimal before. Decimal to percent is moving 2 places to the right. Percent to decimal is going to move 2 places to the other direction, to the left. So let's do an example like that, just so we have something like that here in our notes to refer back to decimal, percent to decimal. And we'll have 2 parts to this one. So let's say we had 28%, and I wanted to say, what is that as a decimal? So right now the decimal point's right there in the percent part of it, and if I move it 2 places to the right, doing this in the different color here, then this would equal 0.28. So what are we doing in a sense? If you had to explain it to somebody, what are you essentially, or in actuality, what are you doing? You're dividing by 100, and then you're removing the percent symbol. So divide by 100 and remove the percent per 100. In other words, remove the percent symbol. So that's how you went to that. And the decimal goes 2 places to the left. So throw a little twist in there. What if you had something like a fractional percentage? Is that possible? Sure. 1 over 3, you're not sure what that is, you can put that into a calculator. 1 divided by 3 gives you 0.3 repeating. So this would equal the same thing as 0.3 repeating. We signify that with the little bar above the 3. 0.3 repeating percent. I still want to change this to a decimal though. Right now it's not a decimal, it's a part of a percent. So it's kind of like a decimal percentage, but it's not in decimal form yet. I want to change this to decimal form. Do the same thing here. We still need to take this and move it 2 spots. So that would move it here. I need to move it 1 more spot though. So is it possible to have something like 0.003? Sure. And that is our final answer. So 0.003 is going to be my answer there with the bar over it if I'm going to have an exact answer. If I told you could round it off, then this would repeat 3333, so you'd round off the 3 wherever to a 3, because the next digit would still be a 3, which would be less than 5, so we would round down. Kind of just depends on the question there. So let's do example 4 here. So let's do a practical problem now. If 763 out of 3,304 students at a school are Hispanic, determine the percent of Hispanic students at the school. So what's your important information here? Well, I would say this and this, you got to use those two numbers here. 763 out of. When you hear that phrase out of, you should be thinking divided by. So something out of something would be like this. 763 out of the total 3,304. After that, that would be really tedious to do using long division. So let's get out our calculator here. Divide it by 3304. And we get about this. I'm going to go to 4 decimal places for right now. I could go farther, I could go shorter. It kind of just depends on what the directions of the question say. So this one, 0.230, this I would round to 9. I would not round up because that's 4 or less right there. So 0.2309. Notice it asks what percent. So we would take this. I did round this off, so I'm going to make this a squiggly equal sign, approximately equal to. And so that would be about 23.09%. I notice I didn't draw in the little jumps here. If that helps you, you can do that, but those don't have to be here. From here on out, if you just know that, just leave those out. So 23.09% is what that is. Is this answer reasonable? Yeah, that seems like this out of this seems about 25-ish%, a little bit less. Seems like a reasonable answer right there. So let's move on to example 5. And for this one, before we start this one though, I'm going to write down how you do percent change. I heard there might be a guest speaker in a little bit coming to stop by to pay a visit to us. Huge baseball fan coming by to pay a visit. So percent change is the latest amount minus the previous amount over the previous amount times 100. Now at first that may seem kind of convoluted and you're like, what is going on? Let's do an example to put some meat on the bones of this percent change equation. So here is my example here. In 2000, and I'm gonna bring in my guest speaker just a second here. We're recording. Okay, so guest speaker here. This is my lovely mother. Say hi to mom. Hi mom. Hi mom. And she is a huge baseball fan. You'll notice this question is about the Chicago Cubs, her favorite team of all time, and she knows everything about the Chicago Cubs. So, mom. In 2010, how many games did the Chicago Cubs win?
71.
No, that's how many they won in 2011. Trick question. Haha, I told her earlier that they won that many. Okay, how many did they win in 2012? So in 2011, the Chicago Cubs. You don't know? You're a huge baseball fan. Why don't you know this?
Didn't your mother tell you not to lie?
She just asked me, "Are we done?" Yes, we're done. You did poorly. You did very poorly, Mom. I'm very disappointed in your Chicago Cubs trivia knowledge. I thought you were a better Cubs fan than that. This is the 2 most recent seasons. As of the recording of this video, doesn't even know. So they won 71 games. That's in 2011 though. My mom thought that was 2010. I don't know why. It's not like I told her that the Chicago Cubs won 71 games in 2011 at any point before the video. What'd she say about lying? What'd you say?
I said, didn't your mother tell you not to lie?
Didn't my mother tell me not to lie? No, she never told me that. Never ever. Okay. 2012 they won. They won how many games?
Did you get that?
They won how many games?
Strike 2.
Strike 2.
Like what?
And we're doing baseball? Is that why it's funny? Strike 2? Okay. They won 61 games. And we're going to find the percent change. Okay. So, What are we going to do? Percent change equals the latest amount minus the previous amount over the previous amount times 100. So we're just going to use this equation up here and figure it out from there. So what are we at right now? The latest amount was 61 games. So we're going to put 61 first. And then we should be thinking, well, this is a percent of decrease because we're going from 71. We won more games last year than this year, the previous period, compared to the latest period. And so we have 61 minus the previous amount was 71 over the previous amount. What we started with, in a sense, was 71. So what does this equal? This is 10 over 71, which becomes, if you put this into a calculator, let's do that here, 10 divided by 71 is going to equal this 0.1408, and this we would round off. I'm going to go with 4 decimals again, kind of 4 decimal places. Just depends on what the question asked for. I made a mistake here, or I didn't make a mistake, I just forgot to put it. I was about to put it. That should be a negative 10. If your number is negative, it's a percent decrease. If it's positive, it's going to be a percent increase. So this becomes approximately negative, that's not a negative sign, that's a squiggly line. That's not what I want at all. This is negative 0.1408. And if you change that to a percent, remember you move it 2 spots. So this would be about a drop or a decrease of negative 14.08% for that. Alright, so this is the case here. Let's get out our different color just to make another point right here. If the latest amount is greater than the previous amount, or just greater than the previous, we'll say, percent change is, here it was negative because we're going down from one year or one period to the next. Here now it's going to be positive because we're going up from that previous period to this period. So the percent change is positive instead. So the book has 2 examples, one positive and one negative. I just did one example with you here. So if you want to see some more like this, check out the examples in the book that correlate to what you see there. Those 2 examples, it looks like, would be examples 6 and 7 in the book. It's example 5 though for us. So let's do another one here. We've got percent change and we have something called percent markup. So percent markup, it's very, very similar to what we just did. I'll show you how it connects in just a little bit. So the percent markup, selling price goes first, minus the dealer's cost going here, divided by the dealer's cost. Times 100. So to relate this to what we just did, selling price, that's kind of the latest amount. That's the latest amount you're going to pay for it. And then the previous amount, what the dealers paid for it, matches up with that, the dealer's cost. So we have essentially the same equation here. So really nothing new to learn, just kind of new words to insert in there instead. So latest amount was what you paid for it. The previous amount was what they paid for it, the store, whatever. So I'm going to say there's this place called Fiona's Fashion. Fiona just opened a new fashion store, sells clothes there. Just the hottest thing in town right now. Everybody's going there. Everybody wants a Fiona's Fashion shirt. But Fiona's Fashion, the shirts that they sell, they initially pay $5.83 for those shirts. Little did you know. And then they regularly sell the same shirt for $42.99. Because again, it's the hottest thing in town. Everybody needs a Fiona's Fashion shirt. So find the percent markup. So what's a percent markup going to be? We look back at this, same idea as percent change, just with the selling price and dealer's cost instead of previous amount and latest amount in there. So latest amount, the selling price, that's $42.99. The previous amount, the dealer's cost, is $5.83. So we can write those like that without the dollar symbol in front of that, over the dealer's cost. Is this going up by more than 100%? You look at that, definitely more than double, right? That's more than 100%. So this is going to be something over 100% for sure. What does this equal? You can't do that in your head. You should take out your calculator and take $42.99, subtract $5.83 from that. $37.16 is what that is. So that's how much it went up by. That's from the dealer's cost to your cost. They're charging you $37.16 more than what they paid for it from the manufacturer. And so from here, you take $37.16 and divide it by 5.83, and we should get 6.7339. So this equals approximately equals 6.73, whoops, got that backwards, 6.3739. So this is not the percent markup, this is just the number of times bigger it is. So as a percent, remember, move that 2 decimal places. So this is crazy, 637.39% more. That means they more than, I don't even know the word for that. Is that like sextupled or something like that? Not quintupled. They more than, it's more than 6 times the amount they paid for it is what they're overcharging you, in my opinion. So fashion places like that, I can think of a few stores. I won't name any off the top of my head, but maybe you go to the mall and you buy these ridiculously expensive shirts. I just don't think that's a good idea. I think you should just get the shirts somewhere else. Buy clothing that's not marked up by more than 100% or more than 600%. Literally, this happens quite a bit. These big name companies, they'll buy these shirts and buy this clothing for super cheap and then sell it to you for way more than they paid for it. I think this is crazy. So I think I'm going to write that down. That's crazy. Crazy. Alright, let's do example 7 here. This one I'm going to break into some parts here. These are related questions though. So part A, what is a 15% tip on a bill of $32.40? Part B, we're going to say what percent of $125,000 is $18,750. And then finally part C, 32% of what number is 68. So get out your different color again at this point. What we want to do here is convert to equations first. We want to set these up as equations. We've got this one missing part. That missing part, we're going to say that's our variable. So we're going to use a little bit of algebra here to help us discover what the answers are to these. So convert to equations first, and still in a different color. When you see the word is in the context of a problem like this or problems like these, is going to mean equal. So this goes with this, and you can think of the word of means to multiply. So in the context of these types of problems, that's going to be true as well. So if you see that up here in these problems, we want to do that. So we want to take these and convert them to equations first, and is means equal, of means to multiply. So let's take these one at a time and see what we got. So 15% tip TIP there of a bill on 3240. And before I do this one, pardon me there, before I do this one, tip actually means, if the book is right, this is on page 597, tip actually means to ensure promptness. And somebody back in the day, the legend has it that like the book says, this hurried businessman, he dropped off a few pence, that was their like pennies or cents, on a table as a friendly incentive to the waiter. The waiter's like, oh, I'm going to go get your food a little faster now. So tips used to be given before the meal. Now tips are given after the meal. 15 to 20% is usually pretty typical. I tend to tip 15 to 20% if they do a really good job. Sometimes I'll tip a little bit more even than that. But how can we figure this out from there? So literally, to ensure promptness, tip. How can we figure this out? What's going to be our variable here? We have a 15% tip. So 15% of 32.40. 15% of 32.40. $32.40. We're saying that is, what is it, is going to be, instead of is, I'm going to write equals right now. So is or equals, we don't know, so we're trying to find, is that exactly, we're trying to find out what that is. I'm going to call that x. Let's just go with the most utilized variable of all time, x. So this is the same thing as saying 0.15 of, meaning to multiply. So 0.15 times 32.40 equals x. In your different color, off to the side here, let's just write down that 15% is equal to 0.15. That's where that came from. So that didn't just magically appear out of nowhere. We just changed the percent to a decimal by moving the decimal 2 spots there. So let's take our calculator out at this point and figure that out from there. And so we have 0.15 times 32.4. So you got 486. That is going to be your final answer, $4.86. So if you didn't have, or if you weren't using a card, debit or credit card of some sort, and you just had cash, you'd probably just leave $5, I would imagine, something like that. You'd round that off. To figure out a 15% or 20% tip quickly in your head, you can just change this to 10%. You can move the decimal 1 spot right there, and then you could take half of that and add, that would be 5% if you took half of 10%, and you could add those two things together. So that would be 324, and then half of 324 would be $1.12, right? So $1.12, and then $1.12 plus 324, not $1.12, $1.50 plus 12 would be $1.60. $1.62, and then 324 plus 162, there we go, I got it, is 486. So 15%, a little bit trickier. If you did 20%, move it over, and then 324 multiply it by 2, you'd have $6.48 as a tip instead if you did 20%. So it kind of depends how generous you're feeling, maybe how good of a job the waiter or waitress did. But that's what we would have for something like that. And so part B now, let's say what percent of 125,000 is this? I think I'm going to need a little more space here, so I'm going to create a new page after this, just a second. So insert a blank page after, there we go. And so part B here, let's say we have what we had here. So what percent of $125,000 is $18,750? So now our total right here is this, and then the percent of that is this. So it's still in the same format, something times something equals x, but now we don't know the percent. So this now is our x. This is our variable. Instead of the 15% being there, we don't know the percent. So this is going to be what we say is x. We're saying x percent of something. What is that something? That's that total amount. So the total amount, 125,000, is or equals $18,000 or $18,750. So how can I change this into something that I can actually solve for? I can replace x. It's as if the decimal place is right there, or this is like 1x, I should say. So think of an invisible 1 being there. You move the decimal place 2 spots, and you would have 0.01x as a decimal. So we would change that to that like that, and we have this times 125,000 would equal 18,750. So off to the side here in your different color, let's just write why that was what it was. So x percent equals 0.01x in decimal form. So include that here. Make a little arrow there to say that went with this line right here. And so now at this point, what are we going to do? We're just going to take this times this. That's what we're doing here. If you multiply something by 0.01, it's like, in effect, moving the decimal 2 places to the left. And so this would equal 1250x would equal 18,750. So 1,250. At this point, we could take that and divide by 1250. And so that would cancel out here and here. You'd be left with x, and put that into a calculator to get 18,750 divided by 1250. It's going to give you 15. So x represented our percent. So what is this? This is 15%. Where might you see some numbers like this, just to make this more practical? You might have to make a down payment on a house someday. You might buy a house someday. And you could get a modest house. This is a very modest but contemporary looking house. I think that looks pretty cool to me. Maybe it doesn't to you, but I like contemporary style houses sometimes. Depends how it just looks to me, I guess. But 15% could be a down payment on a mortgage of $125,000, and that 15% of $125,000, you would need to pay $18,750 up front just to be able to move into that house, if that's the required down payment. So something like that is very practical problem here. We're going to be doing lots of practical applications of these sorts of things in this chapter. And then finally, getting ahead of myself here, 32% of what number is 68? So this is pretty straightforward here. 32% times what number? Times x, whatever that is equals 68. So 32% of x, we're saying, equals 68. So as before, change the percent to a decimal. It's 0.32 of is times, and you have 68 here. From there, that's in our different color. Just say that 32% was the same thing as 0.32, just to make that reference right there. And how can you solve for x from here? You could get rid of this multiplication sign in between and write it right next to each other, or you could just go right from there and just divide by 0.32. So you can divide by a decimal, that's okay. That means you're dividing by, this number should get bigger because you're dividing by something that's less than 1. And so this put into a calculator ends up being exactly 68 divided by 0.32, exactly 212.5. And that would be your final answer. So if you plug this back in or think about it in context of the problem, does that seem reasonable? 32% of 212.5 would be 68. That seems like a reasonable answer. If you got something that was less than 68 and you said 32% of that less than 68 number equals 68, you should be thinking, I did something wrong there. So always go back and say, is my answer reasonable? Go back and fix it if it's not. Final example here, let's do one that is an application of one of these 3 types of problems. See if you can figure out which type of problem this is before I get it all up here. So suppose 0.25 liters, I'll say, or 35%. 0.25 liters is the same as 35% of this protein smoothie. So of a protein smoothie, sounds good right about now. So 35% of a protein smoothie consists of 2% milk. Consists, there we go, of 2% milk. And my question to you, what is the volume, in other words, the total volume of the protein smoothie? What is the volume of the protein smoothie? So what type of question do we have here? This, you may be thinking, oh, I got to use 2 somewhere. Think about this in the context of the problem. 2% milk is just the type of milk. It doesn't mean you're taking 2% of anything. That's just the type of milk you have. So that I just kind of threw in there to see if you could catch that. That was just kind of extraneous or superfluous information. Great word, superfluous. Love using that word. Just kind of extra, unnecessary information there. So let's say, suppose this is true. So what is the volume? This is talking about the total volume. So back here, when we thought about these kinds of problems, we would have the percent of the total equals a certain amount. So that's the same thing we're doing here. Percent of total equals a certain amount. I think that's probably even a good thing to write here. So we want to, in general, we're thinking, let's put this in red, percent goes first, and then of, and then the total is or equals the, in a sense, the percentage amount. So let's write that above our equation here. So the percentage amount goes there. And so what is the percent in question? It's not 2%, it's, or again, just a type of milk. So we have 35% of means times, so of the total we don't know. So we're saying that is X equals the percentage amount is the 0.25 liters. So that's the percentage amount in question. So I think that really makes it easy. If you think of it like that, that goes together. Just line those things up, and that should help you out significantly, I think. So let's change this now to a decimal. This would be 0.35x would equal 0.25. We could divide this by 0.35. I didn't mean to cross out the x there. That should still be hanging out on the top here. So divide by 0.35 here and here. That goes away there and there. And this becomes approximately 0.25 divided by 0.35. We're dividing by something less than 1, so our numbers should get bigger on the top. So 0.25 divided by 0.35. That equals 0.714, and it goes on and on. So I'm going to go, I'll just say, I'm going to pretend that the direction said to round to 3 decimal places on this one. So I will say that's 0.714, and my units here was in liters. If I change that to milliliters, just a little throwback question to the metric system chapter that we had earlier, this would be about, you'd move the decimal 3 spots to go to milliliters. You often see milliliters abbreviated on bottles or cans of things that come in liquid form like that. So we're going to say that this is a 714 milliliter milkshake or protein smoothie. Sorry, not a milkshake, but a protein smoothie. Milkshake sounds good too right about now, but we'll say that that is our answer in 2 different forms. So it kind of just depends what they would say, what they would ask for. Does that make sense? Is that reasonable to say that this number would be bigger than the 0.25? Yes, because the 0.25 represented this certain percentage of the whole thing. So it should get bigger. Our total should be bigger than the percentage amount that we had right here. So one final thing I want you to write down. I'll put a little star next to this because this is really important. We just checked this. We said, is our answer reasonable? So always ask yourself, is my answer reasonable? This is good not only for this chapter or these lessons, but for any math question at all. Is my answer reasonable? If it's not reasonable, if not, please go back and fix it. Don't just say, oh, I got it wrong. Go back and try to figure out why you got it wrong. Figure out what went wrong. Try to adjust the numbers so that you can get the right answer. So we'll go back and fix it. And that concludes our lesson for 11.1.